Welcome to the Lippert Technical Institute. If this is your first time joining us, I'm Emily, your host for today's Digging Deeper segment. These sessions go beyond the basics to help you understand how vehicle systems work together to keep your ventures running smoothly and safely. Today, we're diving deeper into hitch bike racks and some of the details that often get overlooked. Hitch-mounted bike racks are accessories that attach to your vehicle's receiver hitch and let you transport bikes outside the vehicle. You'll find different styles and designs with different advantages to suit your needs. Variations in design accommodate needs like how many bikes you're carrying, the type of bikes, and how frequently you use the rack. A major benefit of a hitch bike rack is that they are especially useful for heavier bikes like e-bikes or mountain bikes, which can be too heavy or bulky for roof-mounted racks. Before we dig into the finer details, let's break down what you're actually working with when it comes to hitch-mounted bike racks in terms of components. Hitch bike racks include several common core elements. Horizontal and vertical arms serve as the primary hanging apparatus, creating the structure to mount the bikes. The longer the arms, the more bikes you can carry. On tray-style racks, the vertical arm is often used to clamp the bike into place on the tray, which is the base for the bike's wheels to sit on. These trays are often shaped like loops or troughs, are usually metal, and these help stabilize the bike during transport. Cradles are loops or holders that keep the bike secure. Depending on the design, they either grip the bike's frame or wheels and are often made from rubber, metal, plastic, or a combination of all three. All of these parts are usually adjustable to fit different bike sizes and styles. And finally, the shank. This is the horizontal tube that mounts the bike rack to the vehicle's hitch receiver and is the foundation of the rack where all the other components connect. When it comes to the bike racks, there's certainly no shortage of variety. Outside of the hitch-mounted options, you may see truck bed racks, roof-mounted racks, even racks designed specifically for RVs and travel trailers. However, hitch-mounted racks remain the most widely used. In terms of design, hitch bike racks are generally offered in three main styles. There's tray style, hanging style, and clamp-on. Clamp-on racks attach to the ball mount shank, allowing you to use a trailer and carry bikes at the same time. Tray-style racks support bike racks by the wheel, which works well for heavier or oddly shaped bikes, and they also tend to be more versatile, working well with kids' bikes, step-through frames, and non-standard sizes. Hanging-style racks support bikes by their top tube and are usually lighter and easier to store. When it comes to transporting bikes, arguably the most important spec to consider when choosing a hitch bike rack is weight capacity. Weight capacity refers to the total amount of weight the rack can support, including all bikes and any accessories. Exceeding this capacity can cause serious problems. A few of the risks you take on when overloading a bike rack are component failure, a reduced product lifespan, damage to your vehicle and hitch, increased difficulty while driving, or even voided warranties and denied insurance claims. Given how critical weight capacity is, let's take the time to really break down the key details and do a bit of math to help you understand what setup is right for you. The first thing we need to recognize is the relationship between your vehicle, hitch, and bike rack. These three components form a connected system, and like any chain, it's only as strong as its weakest link. Your overall weight capacity is determined by the component in this chain with the lowest rating. To get started knowing your system's limits, take a closer look at the tow vehicle. While the subject of vehicle weight ratings can seem complex, when it comes to the bike racks, you only need to understand a few key details. The key detail here is payload capacity. Payload capacity refers to the maximum amount of weight a vehicle can carry, including passengers and cargo. To find this number, you take the gross vehicle weight rating, which is the maximum allowable weight of a fully loaded vehicle, and subtract the curb weight, which is the weight of the vehicle with standard equipment, fluids, and a full tank of gas, but without the passengers or cargo. Once you calculate your payload capacity, you can use this number as a reference when selecting your hitch, bike rack, and deciding on how many bikes your system can safely carry. Now, let's touch base on hitches. Hitches are classified into 5 categories based on their weight ratings. But for bike racks, you'll most often encounter class 1, 2, and 3 hitches. Now, what we really need to pay attention to is the tongue weight capacity, the amount of vertical force the hitch can safely support. This is because a bike rack applies downward force on the hitch rather than a pulling force like a trailer. We also need to note the weight of the hitch, because this weight needs to be accounted for when considering our payload. One simple but also important factor to consider is the size of the receiver tube, which affects the compatibility with your bike rack shank. Many hitch receivers and bike racks come in standard shank sizes, and while shank adapters or extenders provide flexibility and a tailored fit, it's important to keep in mind using these can reduce the overall weight capacity of the system. And of course, we need to talk about the bike racks. While ironing out the style, type, and number of bike racks are all important factors when choosing a bike rack, the weight of the bike rack and maximum load capacity play critical roles when coupled with the hitch and vehicle. Specifically, we need to determine if our loaded bike rack falls into the tongue weight capacity of our hitch and if the total weight of the hitch and loaded bike racks fall into the payload capacity of our tow vehicle. Why does any of this matter? To put all of the puzzle pieces together and let you see the big picture, it's time to cover the math of the situation. Start off by identifying your payload capacity. For example, let's say the gross vehicle weight rating is 9,000 pounds and our curb weight is 4,000 pounds. These are average numbers for a truck. Subtracting our curb weight from our gross vehicle weight rating gives us a payload capacity of 5,000 pounds. Before we move on to the next step, we are going to go ahead and factor in our passengers and luggage. Let's say Mom, Dad, Jack, and Sally have a combined weight of 500 pounds, and their personal items add up to weigh an additional 150 pounds. That would leave us with a remaining payload of 4,350 pounds. Now, the receiver hitch. We want to make sure we have something that can handle the weight of the bike rack and 4 bikes. To play it safe, we are going to use a Class 3 hitch, which are common to be installed on crossovers, vans, SUVs, and trucks. This would give us a tongue weight capacity of up to 800 pounds, depending on the specifics of the hitch, and the average weight of these are around 50 pounds. Adding that to our utilized payload capacity, we are left with 4,300 pounds. The next step is to factor in the bike rack and bikes. We have 2 adult bikes weighing in at 20 pounds and 2 children bikes weighing in at 18 pounds. And of course, we need to go with a bike rack that suits our needs. So we ended up with a tray-style rack that can fit 4 bikes and has a weight capacity of 180 pounds, and it weighs 86 pounds. Now this is where things get technical, because we need to factor in for torque. Torque is the rotational force applied when weight is placed away from the pivot point. The further that weight sits from the pivot point, the more torque it generates. A really good example of this is the way gears work on a bike. A lower gear setting will have a slower speed, but allows you to use less force to move the bike because it has a higher torque, which is great for when you're going uphill. A higher gear setting will increase your speed, but has a lower torque, so more force is needed to even get the bike moving. Torque as it applies to bike racks is the rotational force exerted on your vehicle's hitch when the weight of the bike is suspended away from the hitch's pivot point, which is the spot where the rack inserts into the receiver. The further away the weight is positioned from the hitch, the more torque it generates, even if the weight itself doesn't change. Let's say your bikes are spaced out on the rack like this. The center of the first cradle is 18 inches from the hitch face. The next is 26 inches, then 34, and finally 42. If you calculate the torque for each 20 pounds at 18 inches, gives you 360 inch-pounds, 20 pounds at 26 inches is 520 inch-pounds, and so on. You end up with a total of 2,257 inch-pounds of torque. To understand what this means and how it applies to our situation, we need to figure out the equivalent vertical load. This helps determine whether or not the actual torque created by the hitch-mounted load exceeds your vehicle's and hitch's tongue weight capacity. To do this, divide the total torque by the reference distance, which is the measurement from the face of the receiver tube to the center of the shank and vertical branch of the bike rack. That gives us an equivalent load of about 205 pounds. The final step is to put all of our numbers together and check that we are within the limitations of our setup. Adding the weight of the bike rack and the equivalent load together, we end up with about 291 pounds for our final tongue weight, which is well below the tongue weight capacity of the hitch receiver. This brings our final payload to 991 pounds, leaving us with about 4,000 pounds of wiggle room. But it doesn't take much to tip the scales. What if you swap your hitch to a Class 1 hitch, only rated for about 200 pounds? Suddenly, you're overloaded. Or imagine switching a truck to a compact car with just 1,000 pounds payload capacity. Now, you've only got 9 pounds of remaining payload capacity. Even if you just swap one of the adult bikes for an 80-pound e-bike, your total tongue weight jumps to 389 pounds. Changing one detail can go far beyond what the assembly can safely support. The takeaway here is simple. Always match your bike rack specs with your vehicle and hitch ratings. Understand weight capacities and added torque involved, and stay well within the limits of the system. As heavier setups like e-bikes become more popular, it's more important now than ever to do the math and make smart, informed decisions. Thanks for joining me here at the Lippert Technical Institute. As always, be safe, stay informed, and tow smart.